Alrighty, now the parameters of a binomial distribution. If I go here to my handy dandy formula sheet, the mean and the standard deviation are listed for me, as well as the probability distribution function. So I do not have to bother to memorize these at all. The only thing I have to memorize and check is the bins conditions: binary, independent, n fixed, s probability of success. And then these are just for my AP Stats formula sheet. So I just have to be able to recognize in which settings I'm going to use a binomial distribution. Oh, there's my there's my screencast for you. Alrighty, so let's look here. Now, I did go ahead and write in the calculator steps for you all on the previous video, and I'll do that from now on as well. So my students are going to have to be prepared to go from formula to calculator when most other students can just skip right to the calculator. But we have these parameters and these formulas here. So let's take a look here. Mr. Pinto's 42 AP Stat students performed an in-class activity involving telling the difference between tap water and bottled water. Now, we assume the students in his class cannot tell tap water from bottled water, and we assume that there's a 1/3 chance of correctly identifying the different types of water simply by guessing. So X is going to be the number of students who correctly identify the cup containing the different types of water. Let's find the mean and standard deviation of X. So notice there was nothing about it being normal. There was nothing about it being uniform. There was no probability distribution or any data for me to evaluate. I was just given a setting. So that means it's got to be one of my special types. So let me check these conditions here. Well, let's see if it's binomial. Binary. It either does or does not happen. And I would say this is binary since they either do or do not guess correctly. Independent. I can assume that from each student, they might giggle a little, and maybe some of them will have hot hand fallacy and think, well, they've gotten 2 wrong, they're due for a right, but I can assume that they're independent from one another. Next up, and fix is going to be the total number of trials. Well, I have my 42 students trying it out, so my number of trials here is going to be 42. And then S success we saw was 1/3. So this would meet the criteria for being a binomial distribution. So I'm going to say that X, which is the number of students who correctly identify, is going to be a binomial distribution with parameters n equal to 52 and p equal to 1/3. So mu of x is just given to us by np. And again, don't stress about this. The mean is right here for a binomial distribution. So I'm going to go here. So n is 42, p is 1/3. And if I multiply those together, I'm going to get 14. But something's a little different here. If we're in a probability unit, shouldn't my probability, my answer be between 0 and 1? And you'd be absolutely correct. Notice that I wasn't asked to find the probability. I was asked to find the expectation, which means this is a number. And in stats, you know that if we get a number anytime, that number will always have units. So here, this mean of x is 14, and x is the number of students. So the mu here of x is going to be 14 students. So in the long run average, we'd expect about 14 students to correctly guess everything. Now let's find the sigma, and this formula looks scarier than it is. It just says the square root of np times 1 minus p. So we're going to take the square root here of 42 times 1/3 times 2/3, and I'm going to get an approximate answer here of about 3.06 students. So on average, the number of students who correctly identify the type of water in the cups varies from the mean by about 3.06 students. Not too shabby. Alrighty, so that is how we find the parameters. Well, let's take a look now at putting it all together, because on the AP exam, you're going to have at least 2 questions that are going to deal with a binomial distribution, checking the conditions, finding a parameter, or finding a probability. Then in the FRQs, it has been showing up recently for the last 4 years. There's going to be some element of a binomial distribution in your probability question. Now, last year, the entire question was about the binomial distribution. But in the years before that, the part C of question 3 was our binomial. So we do need to be ready to identify when it is or is not binomial. So let's take another look here. In 1989, we released the first really important survey of American habits, and it turns out that the overall percentage of American households who place the toilet paper over is going to be 68%. Now, we're going to select a random sample of 50 American households. So again, nothing about normal, nothing about uniform, no discrete random variable, nothing about transformations, nothing about combinations. literally just a statistic and a random sample being selected, and I have no data to evaluate, that must mean this is probably going to be a special type of distribution. So let's check it out. Binary, well, yeah, they either place the toilet paper over or under. Independent, because I can assume what my house does won't influence what your house does. And fixed, well, we're only taking a sample here of 50, and then the probability of success is about 68%. Now, in a bonus lesson for this unit, we're going to learn another way to verify independence. But for now, these are two typos here. So this one is actually going to be that exactly 35, and this one's going to be that at least 40. Okay, so based on this context, we believe that x is a binomial random variable with the parameters n equals 50 and p equals 0.68. Okay, so we want the probability that there are exactly 35 households that place a toilet paper over. So I'm going to go here to my handy dandy formula sheet. X is 35, so anywhere I see x, I'll do 35. P is 0.68 and n is 50. So you can see this is really just a fancy substitution problem. So 50 choose 35, and 68% of the time they'll place the toilet paper over. And that's going to happen 35 times, 35 successes, which means my complement, my failure rate is 32%, and that will happen 15 times. And if I type this into my calculator, I'm going to get about 0.1168, which will be my answer. Now the calculator steps in your calculator, you're going to go to second vars. And on the AP exam, you can use your calculator speak as your work. Now, not proper mathematics, but again, it's a standardized test, so I'll give a little leeway here. So I'm going to go second vars on my calculator, and I'm going to find the command that says binom PDF. And notice that it's PDF because I want a precise value. That's PDF. So here I'm going to have n equal 50. I'm going to have p equal to 0.68. And I'm going to have x equal to 35. And if I type this into my calculator, I'm going to get the same answer here. So for my students, you'll be, and anyone actually, you'll need to be prepared to use the formula, but you can also use your calculator. But you need to understand the connection between the inputs here and the formula. And notice that too, when I use the calculator, I also had to define everything. So even though we've defined it here, I can't just put what is on my screen. I have to literally tell the reader what I am doing so that they understand my train of thought here. So that is an exact question. Let's find what is probability of at least 40. Now this one's fun because if it's at least 40, that means it can be 40 or more, right? It can be 40, 41, but can't be 39. So here we have two options, because think about it. We have 50 households to choose from. Either 0 of those 50 could have over the toilet paper, or all 50. And if I want that at least 40 has it, so let's think about our broken noodle here. So I can have 0, 1, up to 50. So I want that at least 40 people have it, which means I'm going to ignore 0 through 39. I don't care about them. I'm going to take them out of my sample size. That's the same as 1 minus the probability that it's between 0 and 39. Now that's going to be an alternative method. My school, we have the N-Spire. So I'm just going to do what I would put in the calculator. This is a binom CDF problem, and notice now cumulative, because there's more than just a precise value. There's a range of values. So my lower value is going to be 40, and my upper value is going to be 50. My n is 50, and my p is 0.68. So when I type this into the calculator, I'm going to get a small probability of about, oh no, I was not prepared, so let me see. I'm going to do lower, upper, 1 minus from 40 to 50. All right, I'm going to get about 0.0437. Now, maybe yours looks a little bit different. It should be about that based on my logic here, but you know, I make mistakes too. But that should be our final answer, is about, there's a 4% chance that at least 40 of these 50 households will have the toilet paper over. And again, we're going to have a separate video that's going to go through calculator commands, so don't stress if your numbers aren't matching or you're not sure where to find these commands. I'll show you in a following video. Now, to find the mean and standard deviation, we said that x was binomial. So we know that to find the mean and standard deviation of a binomial random variable, we're just going to plug in. So mu x equals np. So that's going to give me 50 times 0.68. And again, this is going to give me 34, and it's a number greater than 1, so it's not a probability. It's got to have a unit. Well, x represents the number of households. Now we're going to do the same thing for sigma x. We're going to take the square root of np1 minus p. We'll take this. I'll sub everything in. And it looks like the standard deviation for this binomial distribution is about 3.29 households. All right, so you can see an exact, you can see a greater than. In that following calculator video, I'll show you all types of different examples and how to use the calculator and then the parameters. So we have just a few more lessons left in this unit with a special type of random variable. But for the binomial distribution, all you got to know is how to use your formula sheet and then to check the conditions. And those conditions are binary, independent, and fixed probability of success. So that's a little bit more about the binomial distribution, and stay tuned for our last special type of distribution, which is going to be the geometric model.